This is the third video for the Fall 2018 Exam 2 review. We are going to start with number 8 and talk about each of these. So for the questions here, you're going to be actually calculating, for example, the sine of pi or the sine of pi over 3, and then simplifying them using arithmetic. So let's get started. I've already written down A here, except I didn't write it down correctly. So I think this is 3 pi over 4. So negative 3 pi over 4, if we think about a circle, this is actually going to end up over here. And remember, tangent in this particular quadrant is equal to 1. It'll be positive. So we get 3 times 1 minus the sine of pi would be over here, and that actually is 0 because it intersects the x-axis. So we get a value of 3. Part B of this works in the similar way. We're going to start with taking 4 times the cotangent of 5 pi over 4. Remember, that's actually going to rotate down past pi. And in this quadrant, tangent and cotangent are both positive. And in fact, remember, when pi over 4 has an odd numerator, it doesn't simplify. So we get a value of 1 or negative 1. So here we actually get a value of 1. Minus 3 times the cosine of pi. That's going to rotate to here, and cosine there is negative 1. Plus 2 times the secant of pi over 3. So this one we have to think about a little bit more. Pi over 3 is up here. Our point on the unit circle is 1/2 square root of 3 over 2. Secant of pi over 3 would be 1 over cosine of pi over 3, which is 1 over 1/2, which is 2. So we get 2 times 2. 4 times 1 is 4. Negative 3, remember this comes with this. Negative 3 times negative 1 is positive 3. So we get plus 3 plus 4, which should give us 11. So for part C, we've done some of this before, it seems. We get 2 times the tangent of pi over 4, which is 1. We actually found the cosine of pi over 3 up here in part B. We know that that is, in fact, 1/2. So we get 3 times 1/2. Plus 2 times the sine of pi over 3, which is the square root of 3 over 2. We can see here that this cancels. We can also see we're going to need a common denominator. We can multiply this by 2 over 2 so that we have a 2 in the denominator here and a 2 in the denominator here. So we're left with 4 over 2 minus 3 over 2 plus the square root of 3, which gives us 1/2 plus the square root of 3. And here's where you stop. Because square root of 3 is irrational, we can't actually simplify that any further, and we are done. So here's an overview of all of our work for number 8. We've worked out all 3 of the parts for this one. For number 9, I'm actually going to do these in pieces for each different screen so we have room in order to write. Remember, we are verifying identities here, and we're verifying by taking the left-hand side, and we are going to transform that into the right-hand side, which is over here. When we do that, we start with our left-hand side. So I'm going to write this just like I did in class. Left-hand side will be sine x over cosine of negative x minus cosine x over sine of negative x. And then we're going to independently transform it into the right-hand side. The first thing we need to do is use our even and odd identities in order to eliminate those negative signs inside of our argument. And in fact, cosine of negative x is just equal to cosine of x. So that one isn't bad. But we need to remember that the sine function is odd. So this actually becomes negative sine x. Here what I'm going to do is these two negatives actually become a positive. So when I write this again, I'm going to get sine x over cosine x. Then I'll have a plus sign here because I simplified these two together. And I'm left with cosine x over sine x. But we know using our quotient identities that this is just tangent x plus cotangent x. This is actually the right-hand side, and we are done. We stop. We are absolutely finished. We have now verified independently taking the left-hand side. We've transformed it into the right-hand side, and we are done. Let's look at the next one. So again, we are looking at a problem from 9B on the review. I've gone ahead and highlighted these so that we know which one's our left-hand side, which one is our right-hand side. We'll start with our left-hand side, cosine theta, 1 minus sine theta. I can look at my right-hand side and see that somehow I need there to be a 1 plus sine theta here, which leads me to believe that maybe what I need to do is multiply by 1 plus sine theta as a numerator and denominator. I want you guys to remember a couple of things here. One, that this equals 1. And we're going to end up with a difference of 2 squares when we simplify it. So we're going to get cosine theta times 1 plus sine theta. But on the bottom, we're going to get 1 minus sine squared theta. So remember, kind of as an aside over here, if you need to, that a plus b times a minus b simplifies to a squared minus b squared. And in fact, we're really lucky because 1 minus sine squared theta is one of our Pythagorean identities just manipulated. So we actually know that this equals cosine squared theta. And in fact, that means that this cancels and one of those cancels. So we're left with 1 plus sine theta. I wrote something wrong up here. I'm going to erase it really quickly so that you can see that actually isn't squared. So if you wrote squared, go back and fix it. I'm really sorry. Over cosine theta. This is actually, in fact, our right-hand side. We are done. We stop. We're finished. Remember, we're not solving for theta. Now we'll look at part C. For C, I want you to make very certain that you realize that this entire thing is the left-hand side. Remember, the equal sign is what separates the left-hand side from the right-hand side. So let's look at this and see what we can come up with. We're going to start with the left-hand side. Cosine theta minus sine theta squared plus cosine theta plus sine theta squared. This is where it helps to remember your identities that x plus y squared is x squared plus 2xy plus y squared, and that x minus y squared is x squared minus 2xy plus y squared. I'm going to use these as I fill in the next steps. So we should get cosine squared theta minus 2 sine theta cosine theta plus sine squared theta plus, and then we'll work on the second part of this, cosine squared theta plus, scoot this over a little, 2 sine theta cosine theta plus sine squared theta. So let's look at some things here. We can take this, and they end up being a 0. So let's do that. We're going to get 2 cosine squared theta plus 2 sine squared theta. In fact, I can factor out a 2. So I get 2 times cosine squared theta plus sine squared theta, which equals 1. So I get 2 times 1, which is 1. I'm sorry, 2 times 2, which is 2, which is our right-hand side, and we stop here.